Thank you everyone for attending our talk, how dbt transformed FinOps cost analysis at Workday. This is my first time attending Coalesce. So far has been great, learning a lot of stuff from experts. Also would like to share some of our stories with dbt. So I'll get right started. My name is Eric Pu. I'm a senior software engineer at Workday. And my co-presenter is Pattabhi Nanduri. Unfortunately, he's traveling today, so he couldn't make it here physically, but his portion of the presentation, I will show the video recording of it. I'm on the team that I'm on is called the PRS Engineering Tools Group. PRS stands for Performance, Resiliency, and Scalability. Essentially, this is the tools team for developing a lot of the data tools for the internal engineers, analysts, and data scientists to pull metrics, performance metrics data, and to do analysis over using our tools. And we maintain a complete data pipeline and data warehouse, from data warehouse to data science applications. We have also some of our internally developed custom tools to empower our workmates with data-driven decisions at their fingertip. Next, I'm going to start the video from Pattabhi. He's going to kind of go over the product that we built around FinOps cost analysis, which we call it the Opus platform, which stands for Optimized Usage Optimized Platform for Usage and Spending. So this is a new platform that we work together with the FinOps team, that we provide the technology, the data platform, and they have built up the BI applications on top of it to do FinOps analysis. So let me play the video portion first.
Hi, my name is Pattabhi Nanduri. I'm a senior data engineer working for Workday. I work in a team called Integrated Business Planning, and Integrated IBP team is a business team executing FinOps operations led by some FinOps managers, few FinOps managers. It's basically comprised of analysts, demand planners, cost optimization leads, and engineers. We are responsible for cloud costs and developing cloud cost consciousness culture throughout Workday. So the business problem we had to begin with is understanding the costs and cost drivers of the public cloud from AWS and GCP, the two being the most used cloud providers. We also had the problem of identifying the cost optimization opportunities, like right-sizing the instances, wastage elimination, and also managing savings instruments like reserved instances, savings plans, etc. We also have to do attribution of costs by teams, by application services, by customers, by tenants, etc. We also have to do forecasting of the costs for the future spending, for future spending, and we also have finally reporting necessity with self-service capabilities, team development, access controls, which are at a row level access and for SOX compliance. We had a few technical problems. We evolved into this newer platform that we are at, having tried a few off-the-shelf products and then replatforming into BigQuery and another reporting tool. And now we are at a different tool. The technical problems we had were like, we have source data, foundation source data from AWS and GCP, which are organized differently, which was causing conformance issues. We wanted to see like-to-like comparison of costs, but since they were organized differently, there were conform issues. We also had all the business logic for metrics, dimensions, all the logic that was developed and trapped in the reporting tool. We also had little to no governance leading to siloed development, which was hindering enhancement work, and also we had issues with data validation. There were also performance issues with reporting as well as data pipelines. And then we had difficulty maintenance of code due to lack of framework for development, testing, CI/CD, etc. And also we had issue of lack of customizations in the tool set. The reporting tool we had wasn't being closed source, not being open source, had issues with customizations. So these are some of the dashboard application dashboards that we built. This is a cloud cost management application. So we had customized this, and this is in Lightdash. One of the customizations we did was this tabbed dashboards. So we had usage summary, wastage elimination, compute detail, the big spenders of compute, the databases, and then also for forecasting and all the financial related aspects, financials dashboard. So when we click on this, we see different dashboards rendered within this frame. We also have filters on the top, and these are some of the reports that we developed. So as you can see, this is at a whole Workday level, the actual product spend for the current quarter, product usage spend trend. So as you can see here, we have compute instance, block storage spend, databases, etc. Same way we have compute usage trend by months or days, which is basically time period. And then there is compute instance counts. So different types of metrics that are displayed. And here, in the next one that I'm going to show is, as we click to the compute details tab, we see the compute, more details on the compute that we spend on. So here you can see the current quarter processor usage. We have Intel taking up the bulk, and then there is AMD processors. And we have instance CPU trend by OEMs. We have memory optimized CPU trends.
It's a video.
Again, memory optimized instance count, just slightly different. And here we would see, again, the same thing, but different types, like by general purpose CPU, general purpose instance counts, and the current quarter instance count. So here you can see the different types of CPUs color coded in different colors. And this is a list report tile with different processor shapes and the counts. Now, these are some of the dimensions and metrics we have in this new data lakehouse that we built. This is not an exhaustive list, but these are some of the main ones we use. As you can see here, we have some hierarchies and some dimensions. So one of the hierarchies is a product dimension. We divided the product dimension into 8 levels. The first level being like AWS product or GCP product, and then split down to like 7 more levels so that we can roll up by the product. And then we also have project hierarchy, which is an organizational project hierarchies, not a people organizational hierarchy. People organization hierarchy would be on the platform owners, focus owners. And then we have some metrics like total cost, total committed purchase savings, instance hours, total count star, which is like the number of instances, etc., and then effective cost, etc. So the initial version of the product dimension we built had, as I said, 8 levels, and the initial version was like built with SQL. And out of the 8 levels, this SQL, this snippet of the SQL is just for 1 level, which is product level number 3. It might seem okay, but what we had to do was we had to extract this data out of AWS cost and usage report, which is a file we get with around 400 to 450 columns and about 1 billion rows a month. So for 2 years, we had like almost 20 billion rows, which is a decent sized data. And as you can see, this is pretty long SQL. And I'm going to show how DBT helped with us do this easily and iteratively into what I'm going to show. So again, this is the product dimension, the distinct of product dimension values, put in a spreadsheet as a pivot table so that it's easier to explain. As you can see here, we have these instance types, which is at a lower level of the product. As you can see, the instance sizes and shapes. So when I go here, we would see the same things like instance shapes here. So compute instance is one of the big spending for the cloud costs. So we have compute instance, and then the subsequent levels as compute optimized, general purpose, memory optimized, and then the processor type, whether it is AMD, Intel, Graviton, and the machine series, the machine actual shape. And we also have block storage, which is part of compute instance, comes as attached block storage to the compute instance. So we spent quite a bit on that. Block storage as well, so it is promoted to a higher level because as business wanted to see it at that level. And then we have other things like Redshift, the marketplace costs, the ML instance costs, database costs, and so on and so forth. And just pay attention to these highlighted spend categories, product categories. There are credits and refunds. And then there is also data transfer. So the credits, refunds, and data transfer during the initial version we had were part of every other level. So for example, credits we get credits for compute, we get credits for database, we get credits for Redshift, for example. Same way data transfer happens at all levels, like database, compute, storage. So these were all in the earlier iterations were at a level 4, level 5, like that. But we had to, because business wanted, we had to promote it to a higher level. And we were able to do it thanks to DBT's templating easily, quickly, easily, and iteratively. And we could deliver this kind of product dimension hierarchical structure. So this is some Jinja macros and Jinja templating that we used. As you can see on the left is a macro snippet for select columns. So we had macros for select columns and macros for filtering. So for instance, product dimension, how do I define product dimension? And there is a criteria, and those would be the filters. And like, for example, the product code is EC2, product service code is EC2, and product family is compute instance or compute instance bare metal. So we had macros for select columns, and we have macros for filters. And macros for select columns and macros for filters. And in the next slide, I can show how the generated SQL looks like. So we have these select columns. As you can see here, I have filters, macro filters, and in the generated SQL, those filters were replaced by the actual code. So credit refund filters was like, if line item type is credit and our line item type is refund, it's a refund. So the macros replaced this filter with the actual code. And the select columns also, you can see when the select column also matches, like then case and all this big chunk of code is put into the generated SQL. So how this helped us is in the initial levels, these credits, refunds, data transfer, which was at the lower level, for promoting it to higher level, all we had to do was move these filters around. We had to move this filter up, and then that became from product level 3 or level 4 to level 2. And we were able to do it very easily and effectively and iteratively in a short amount of time. So definitely this macro framework of Jinja within DBT helped us do this easily. We also had another issue. I'm not going to go over all this text on this slide, but for the forecasting module, we had accounts, actuals, actual spend for accounts, budgets, and forecasts. The situation here is that we would have one or the other. The only thing that is tying is account. An account might have actual spend, may not have budget or forecast, might have forecast, may not have budget or actuals. So those were mutually exclusive entities, which may or may not happen. And because we had the materialization ease with DBT, we were able to iterate that quickly and were able to eliminate outer joins. The earlier tool we had to do with outer joins because there is one or other missing, and we had outer joins where we were doing an outer join with filters causing a lot of data validation issues. Numbers missing, filters on the outer joins, it was very tricky. And with materializations in DBT, we were able to quickly materialize, quickly iterate through the effective way of generating some dummy rows and converted all of them to inner joins, and our data validations and data integrity was well explained and well maintained. Thank you. Over to you, Eric.
All right, thanks, Pattabhi. So this is a quick overview of the Opus platform towards the business users. You see a lot of the dashboarding. And now I'm going to kind of go a little bit deeper down to the data platforms that we built and some of the DBT practices we did that really helped facilitate a lot of the development for this platform. So our current stack is composed of the database layer, which is we use Trino as a primary data connector for all the databases and data sources underlying. And the primary data store we have today is both Hive plus a Delta Lake data warehouse. And then Trino is allowing us to bring in data from all kinds of platforms, and it supports lots of sources. So some of them, for example, like AWS Core Data, which is delivered to us in a S3 bucket, and then we map it through Trino into our data warehouse for the query downstream. And then other information, like we also correlate information from Prometheus, where it contains a lot of the performance metrics from applications and cloud environment instances. So we kind of use Trino to connect all these things together. And for data transformation, we currently primarily use DBT. It's very powerful and can do all the transformation in the data pipeline. And all the data marts that we built are directly connected to Lightdash. So Lightdash has a very close integration with DBT. So we're able to take the data marts produced in DBT and bring them into Lightdash. Now take a little closer look at what we use DBT for. So basically DBT, a lot of our engineers, data scientists, they like to use DBT for some of the SQL to do their model designs. Once they finish their model design, next stage is to convert some of these data models into actual data models that are going to be productionized, which involves adding a lot more feature functionalities into these models in order for them to run on the actual ETL process. And once that customization is done, they're pushed onto Airflow for ETL and publishing to Lightdash. That's whole CI/CD pipeline that runs all this stuff. So how do we use DBT Core? We basically, so I list a bunch of things here. I'm gonna go through each one one by one. So when we first started with DBT, one of the things that we wanted to do is to make sure we apply DBT best practices. So as you know, that DBT is a very convenient, easy to use tool. Basically, users just have to write SQL and be able to query the database and perform transformations. However, very quickly, people could start writing, inefficient queries. And that is one of the problems we wanted to kind of manage and control so that users are able to write queries that follows kind of the DBT best practice and also some of our internal guidelines on how to create those models. So one of the things we do is we use DBT macros to support that development process. Essentially, what we do is we developed our own internal DBT macros package that lays out the kind of like a guideline or a template for a lot of these model development. And I'm just going to kind of show a little bit of our project structure. So very early on, we kind of have pushed this paradigm of the setting up the source, staging, intermediates, and marts. So sources is essentially data models that connects to your data sources, right? Defining the source, that's how you bring the models in here, the data into your this data pipeline. And then the staging models, so we are restricting that to purely perform transformations. So there's no aggregation or joining logic. You'll develop inside staging models. Now, if you were writing raw SQLs to do our models, obviously you can do all these things. But however, we have a macro template framework, which I'm going to show in the next few slides, that shows how we kind of control this model behavior so that user develops the right, correct staging models. And then for intermediate models is where users can do more complex operations for the for the data transformation. They can do group by, joins, and unions, all in the intermediate stage. And another key thing about staging versus intermediate is in staging models, we are only allowing ephemeral materialization. So we don't allow table or incremental materialization in staging layer. Now, the intermediate layer, we almost always have the user pick whether it's a table model or whether it's an incremental model. Now, the reason is because we are kind of enforcing group bys in intermediate, so we ensure that we don't like rewrite the same source data again. We always make sure the data is aggregated so they're performant, because as you can see, the next stage where users develop the data marts that connects to the BI system, we wanted to make sure that BI system's query speed, everything will be performant and efficient. So we kind of provide assistance to the user for each of these type of models. Kind of just want to show a little example here about like what the source macros looks like. So here I have a Prometheus source macro, right? So this source macro, as you can see, there's a few definitions in here that we just apply across all these source models. One is the materialization. We kind of control the materialization here, so users don't have to worry about the details of how to do this stuff. And one thing about Prometheus data sources is when they come in, they have a specific way of partitioning this data. This is important because our Prometheus data source actually generates a huge amount of data. And if the user don't do the right partitioning over this data when they query it, they could very easily query a huge set of the full table scan over that data. So we, at very early on, we wanted to ensure that all the models, our user rights, are efficient. So we kind of built these partitioning definition inside the model themselves. So when the user makes a query to it, they'll be able to supply the correct parameters, and the source macros will generate this query that is efficient. And another unique thing about our Prometheus metrics data that we collect is that we kind of do a aggregation before we query the raw data, because the raw source Prometheus data is huge, right? It's very granular. So what we do is we query over a certain period of time for these data. So it's kind of like already aggregated to some extent. But when we do that, each record becomes 4 records. Essentially, they contain these fields with the function, the aggregate function that it performs. So user kind of have to do a pivot operation over this data. So what we do here is we kind of do that pivot operation for the user. So when the user is actually working with this Prometheus data, they don't really have to do all these things in here, right? So to the user, when they wanted to reference this model, all they have to do is just call Prometheus source and specify the source and the metric they want to use, and that's it. And everything, all the nitty-gritty, all the small details are all contained in that source macro. So we kind of built a few of these kind of source macros to work with the variety of data sources that we have internally. Some require specific partitioning, some requires some transformation. So all these things that can be built in there, so users don't have to worry about the details. Just one step easier for them to use dbt in their development. And next is the staging model. So for the staging, intermediate, and marts models, we kind of have this paradigm of where the user will specify a model spec. So the model spec is essentially user defining what their model is doing, or what that model is, right? It's a very declarative form of stating what your model is about. So here you can see that we take few parameters from the user to asking them to tell us what the model is about. So here they can specify the table source, which can either be a ref or a source to their, the source they have, or they can use one of these Prometheus sources, and reference it. And then they will give us the description version and tags. Now these are information we want the user to supply. That's why we're making them part of the parameters on there. Now there's other things. You see that materialization is actually not one of the piece in the spec. The reason is because we don't really want the user to write staging models that actually materialize as some concrete form. So we kind of block that out. So this is a very nice way for us to specify what the user is allowed to do in this system we have built. And another unique thing you see here is the dim columns and the fat columns. So when you typically write a data models, you'll be able to specify all the columns, but you don't really distinguish between dimensions and facts at that early stage until you reach the semantics or the BI layer where you're exporting the data marts and exporting the semantic layers. But here we are kind of having the user at very early on define what these columns are. Are they DIMs? Are they facts? So that way we can carry this information along with the model's life cycle through this whole pipeline so that you only define these column types once, and that information gets transitioned into your, until the final stage of the data marts where you are pushing those columns into the BI system where those definitions are already applied. So just makes things a lot easier. And as you will see that because all these things are defined in macros, users are able to reuse a lot of the dimension definitions in different models. And so we have the counterpart, which is the generate staging model. Essentially, it just generates a lot of the model logic around it. So you can see that when users are defining new models, they can follow this setup and just declare what the model is about, and then we'll generate the rest of the code for the model to ensure that the model they write will work efficiently. And when we reach the int model spec, you'll see that we actually take a little bit more parameters from the user. It's also a way for us to express what we support, like for these models, right? So one of the things is materialization now is supported. So users are able to define what kind of materialization they want for the int model, whether it's increment or whether it's table materialization. And there are a few additional ones like onjoin, aggregate types, and roll up. Now, onjoin is basically a condition where user can define exactly what they want to join. If they have two models they want to join together, they can use the onjoin definition here. The reason we wanted them to declare the types of join they want to do is because we wanted to perform additional checks over these joins. So for example, later on in the slides, you'll see that we actually allow some testing done automatically on these joining conditions. So it gives us a very easy way to apply a lot of the best practice on these data models. Now the aggregate type and roll-up period works with aggregation. So a lot of times you materialize these models into say, an hourly table, right? And then what you want to do additionally is maybe materialize it as a daily table. So you have different ways of aggregation so that when you send them to the BI system, if you don't care about the hourly resolution, you could get much better performant dashboards through just using the daily models. So we want to make sure that roll-up process is very simple for the user. So as long as you use this definition here to create a roll-up of the existing models, all you have to do is just kind of state that, okay, I want this model to be a roll-up of that model, and then we'll take care of all the rest of the bring columns in, which field to aggregate on. So all these things are taken care of automatically. And another unique thing about these roll-up and types is that our BI tool has some unique optimization. Lightdash has some unique optimization around datetime fields. So during the roll-up, if the user declares, this period, this field is used for roll-up, we're able to generate some optimized data to make that query just a little bit faster. So, and you can see that we also have this generate int model, which is the counterpart to this int model spec. So you send an int model spec into this generate int model, and it will produce the intermediate model for the user. And here is just the list. Okay, and then when the user actually uses it, all they have to do is just call it generate int models, give the model spec, define all these things. And the dim column, you see that it's also a macro. The dim column where they specify the name, and actually it's a little bit more complex than this one. Here you can actually supply a few more information, like the description of the column and things like those. And some of the definition that users specify actually gets carried all the way through the whole data pipeline into the final models. So you see here the user defines some dims, some facts, and so yeah, very early on they're giving these columns already some additional definition. And the good thing about dbt is that all these macros are all living within the dbt scope. So you can use a mixture, right? You can write using the framework, what we provide for the user as a definition or as a template to start with, and then use that model for additional add-on type of SQL you wanted to do with it. So it's very flexible. You can kind of mix and match and shift between various things. For new users, they can just simply use what we provide, and it makes the whole development experience very easy. They don't have to worry about a lot of the optimization, the partitioning stuff that's happening inside these models. Okay, and then finally we have the marts models. Now you see the marts models, we accept a few more things, and also we take away few things. Now, what's interesting about the MARTS model is now we are designating the MARTS models purely for the exporting to the BI system, which is the Lightdash. So here we are allowing the user to add a few more information pieces into their DBT models. So they can declare their group details, groups, some attributes and SQL filters. Those are very Lightdash specific parameters. Now we're allowing the user to define on their DBT models because that's where the model definition lives, right? So users do not have to take their DBT models, generate the YAML file, then maintain a separate file with all the Lightdash semantics on top of it. They just maintain a single model spec and define everything in a single place, and we'll make sure all the rest of stuff will be generated. That's what our tools group does. So here, again, we took away the materialization here. We only allowing materializing as views because that's what the BI system requires. So you can see we put quite an amount of restrictions on these models. However, it gives us a very structured way of constructing models and make sure all these models are performant and do what they need to do. And also the good thing is we don't really have to educate users that much. So a lot of times when you deploy these applications internally in enterprise system, your customers, which are internal users, they just want to get on things very quickly. They don't want to spend 2 weeks, 2 months to learn about this system, right? So this gives them a very quick way to develop efficient working DBT models. And if they want to dive deeper, obviously they can still learn all the DBT and do more stuff with it. Yeah, so that's what we do. And the nice thing about declaring everything in DBT models and macros is that all the documentation, we kind of get it for free, right? So if remember we allow the user to define descriptions over the models, and they also are able to specify description over the dimension and columns. So we take all these descriptions, and when we generate the DBT docs, all these information would automatically be available in DBT docs. And then that will be where the user will share information about the models and any additional macros they write. And another core feature that we use a lot is the DBT model lineage. So you can see this is the actual snapshot of the sort of the model branch of our repo, right? So there's lots of models here. And then one of the key things we use the lineage graph for is that we use that to generate actually a execution order of these models. So the model dependency are all being sorted by DBT, which is great. And then we take that execution order, we apply additional information on top of it. Essentially, we profile all our models to make sure how much resources they need, how much CPU, how much memory they need, and we use that information combining with the lineage graph. We establish an execution plan, which gets sent to our Airflow DAG. And that DAG is able to look at this execution plan and determine how to dynamically scale up the cluster based on the workload you have at any stage, right? Because sometimes you have a lot of models, but you don't really need that much resource until you run these source models and maybe the next stage of models, and then until you're at a certain point where you really need to expand the cluster to be able to run all these models simultaneously. So we're able to use the lineage graph plus the profiling information to construct that picture, to make sure our hardware resources are optimized, is performant, and cost effective. And obviously, we use Airflow plus Cosmos to orchestrate our DBT core jobs along with that execution optimizations that I just mentioned. And a lot of times, all these things kind of flow naturally because now everything is defined in one place. We can also add in additional tests to support. So one thing we wanted to really facilitate or encourage users to do is testing, right? And DBT already have some nice testing for the column values. And so that's something we provide it very easily for the users. They just have to define their dimension facts and specify what kind of test they want to run it, and we'll generate it. And plus, additionally, we are taking some of the test cases, test structure from DBT expectations package, also converting them into macros so that users don't have to really know that, okay, I'm working with DBT built-in tests or DBT expectation tests or a custom version of that. They just have to specify the sort of the macros they want to use and to construct test. And in addition, like I mentioned earlier, that because we know what the joining conditions, joining models are, we're able to apply join key tests to ensure they don't have any Cartesian products or doing their join, things like those. So we're able to do additional testing that the user is not even aware of, right? It's part of making that process easy, at yet same time putting the guidelines in place. So you see, we basically write a bunch of test And then some of them just use dbt's built-in tests, and some of them uses the dbt expectations test, kind of making them more user-friendly for applying different cases. Okay, and then for the user, when they define the dims and dimension columns, all they have to do is just say test equals what, and that's it. They don't have to care whether it's from expectations or from that. They don't have to write, because a lot of times some of the data, source data we manage, we kind of know what their criteria are, so we can develop a lot of these standard tests for the users. Okay, and this portion is kind of not really DBT, but it's more on the Lightdash side. But however, we kind of mixed it with the DBT models we developed, which is user access control. So Lightdash has a few different ways of implementing user access control. It can happen at the row level, or the column level, or the table level. Now, they do it a little bit differently, because the column and the table level is actually coming from Lightdash's internal attributes, the facility in that. For the row level access, is actually done at a SQL filter. So we have some detailed ways of how to do this one, how we do the validation against some of the user access control bridge that we have established. So what users have to do is, all they have to do is just on the column they want to define, just specify they wanted to do a validation, do a user access control over that or not. Once they do that, a macro generating framework will basically pick up that detail and add in the necessary SQL filters on top of it. So when the models gets published in Lightdash, and when they open up the charts or dashboard, if you don't have the access, that underlying query will essentially block you from querying that data. And similar things with column and table level access. So all these things are defined within the DBT model specs that I showed earlier. Okay, and then lastly, I want to mention about one thing we do with these DBT model specs. So very early on, we kind of discovered there's multiple file formats you kind of have to work with DBT models. One is the SQL file, one is the YAML file. And you kind of have to always keep them somewhat in sync, right? So there's some kind of work you have to do. You could use something like CodeGen to generate your YAML files. However, you still are responsible for maintaining this, making them in sync, making sure you remember to update one file versus the other. So it's another little learning curve for the new user who are onto DBT. So what we did is we kind of wrote additional functions in our macros that kind of does a generation of these YAML files for the user, because they already defined all the specs in the model spec already. So they already declared everything. We don't want them to declare something again and try to maintain everything in sync. It's just too much, every little overhead we wanted to eliminate for the user if we could. So what we did is we added in each of these generator macros, a thing that actually generates the YAML file. So what it does is, when DBT invokes this model, it basically does the parsing first. And everything the user defines in macros are already generated at the time when this generate YAML spec is invoked. What this macro does is it basically takes that model spec, which is already all parsed, everything is all resolved, and take that and produce a YAML output of it. And that YAML output, it can be used in conjunction with the DBT model they have. So kind of like keeping two things always in sync. And also we build some additional tooling around this stuff to make sure it works. Now this brings me to the final point about DBT is DBT is open source. And the thing we really love about open source is that you can really integrate with it, right? And sometimes you might want to do something that it doesn't really support in the package itself, but you could build it out yourself. And by DBT, everything is in Python, we could very easily plug into that. And here is what we kind of did. When we wrote that operation over there, in order to invoke that generate Lightdash YAML macro, we kind of have to run the DBT model. We have to do a DBT run in order to invoke that code. Now, what we found is, in our setup, obviously, we use this tool from Ultimate AI called DBT Power User Tools. I'm sure many of you probably heard this tool. And they also have an open source counterpart. So we kind of took some of the interesting things they did and learned from these guys of what they did. And we kind of built out a Python tool that basically brings in a DBT project and performs the parsing portion. And once the parsing is done, we kind of have it invoke that generate YAML macro. So it could be much faster. We don't actually have to run the model to invoke the macros in there. And we are able to optimize the performance a little bit and kind of use this in conjunction with generating the YAML files. So now to our users, we kind of solved every little single step. So when the user uses our data platform, all they have to do is just define the model one time, tell us what the model is, what the description is, facts and dim columns of it, and then we take care of the rest, generating the model code, generating the YAML file, maintain them, and make sure the model gets able to get imported into Lightdash. And obviously, at the same time, taking care of all the performance issues around the partitioning, so all these things are taken care of all by the framework itself. The user don't really have to, they only have to worry about what dimensions, what facts they're working with, what kind of aggregation they want to do, and how that data should be surfaced in Lightdash. And yeah, so that's all I have here. So hopefully, any questions or anything?
So I found like the reliability and optimization you just went through like really impressive.
Thank you.
I'm wondering if there were any trade-offs with like say readability of your users for reading these macro-intensive models or like inability to customize them. Like how do you weigh that?
Right, yeah. So when the user first starts with this framework, so they get a template of everything, right? So they can just plug in a few pieces and the model is all working. But it doesn't really keep them away from learning DBT. Because sooner or later, when they wanted to do more complex things, they'll have to still have to learn the DBT, right? It's an easy step to start, but doesn't keep you away from, you still have to learn DBT in the long run in order to work with these macros and understand what the motivations are behind them. Yeah, it is very true, right? So, thank you. Yep. So currently what we do is we have Trino running over Delta Lake. So Trino has some of these monitoring already built in. And they have some facility around, it's kind of complicated because what we do is we have different instances and in Amazon. And they are, we have to kind of know what the instances these queries are running on top of it. And then we have to insert some code into Trino's queries in order to pick up the information, how long did the query run, over what kind of hardware, how much that hardware cost, what's the minute cost, what's the hourly cost, and then bring all these things information together to get a number out of how much resource that query is using. Now, some of the more obvious information, like how many rows did they query, those are more consistent when they actually get into production ETLs, because usually these queries runs over either hourly data or daily data, which is pretty consistent. Yep.
The other part of the question, when you were going over the testing part, so you build the DBT test and DBT expectations, are you also testing your ingestion data? So for example, if you receive a bad payload from a partner, you can...
Right, so these things we are still somewhat at an early stage. We're kind of using like DBT freshness for some of these checks. Yeah, we're also kind of learning. Yeah, this is all like just a sharing of our journey, and I don't see any stopping to this. There's going to be more development going on. Yeah, thank you. Anything else? Yes? Yeah, so it's interesting because we kind of had this very early on because before all this data stack we had a Spark cluster setup, and we have our own internally developed custom query engine. It's like a tool that we have on top of it. Everything was running on-prem. And about 2 years ago, we had a major shift from the on-prem setup into the cloud. And at that time, we realized that what we do traditionally on-prem couldn't really sustain us in the cloud environment. It gets way too expensive for these queries. So we kind of made the jump to DBT Trino. And when we did that, we kind of, very early on, we want to make sure that we don't allow certain unoptimized queries to run. So that's why we spend a lot of energy to develop these framework code. So make sure that the user don't, because if we allow the user to write these broken queries, inefficient queries, it will be more difficult to convert them back into efficient ones, because once it's working in the pipeline, the user don't really have much motivation to optimize them in a way. So we want to make sure at very, very early on we provide the right tools for them to develop optimized, efficient queries. Yeah.
How many users do you have that are using your micros for
Right, so we kind of have a division between developers and internal users. So for the BI dashboard, we have over thousands of users internally that uses these dashboards. And for development, we have about like 20, 30 developers currently working on dbt models. Yeah. Yep.
Hi, thanks very much for your presentation. I like the use of macros to get used to development.
All right, thank you.
But I have a bit of a question. So like when it comes to FinOps specifically, what are sort of the main sessions that you would test? Like for example, do you test for missing costs? You know like in FinOps maybe you
Right.
expect some costs. What are sort of the big things that you're testing?
Right, so some of the things that I went over here is more at a data platform layer, the tooling layer that I had. Some of the information Pattabhi went over is more at the FinOps side. So the FinOps users, they have their own specific tests that they do with their data because they know their data is. And we're actually in a process of expanding the DBT kind of adoption within our organization. And there are other teams that's coming up. And they are the ones that who are more expert at what type of data, what kind of validation they need to do. So yeah, so it's really up to the data teams to adding additional tests. The same things like we can do like for join keys, these things are more standardized, so we could do them. But beyond that, it's really up to the data teams, like what they wanted to use and what kind of tests they want to do. Yeah, all right, thanks. Oh, okay, all right. Yes, in terms of last question. Oh, right now, okay, all right. We can chat all right, thanks everyone. Thank you.